Okay, and they're called angles of elevation and angle of depression. You'll see this again in Algebra 2. They do a couple more hardcore problems too with it, but you get introduced to it in this class. So basically what you're going to do are things are going to be looking at each other. So like you're either going to have someone in a hot air balloon looking at a tree, or like someone in a lighthouse looking at a boat, or like someone's looking up at a flagpole. It's going to be kind of random situations, but there's going to be like a lower and an upper like object, okay? And who's ever doing like the looking, okay, is helps you decide if it's an angle of depression or angle of elevation, or they even just say it in the problem. So basically like the textbook definition of like what an angle of depression is. So like if someone in the hot air balloon's looking at the tree or something on the ground by the tree, they're looking, like imagine them looking straight, and if that person's looking down, that's an angle of depression. So the angle of depression is made with a horizontal line and then looking down. So it's like this is an angle of depression. You're like looking down, okay? And then angle of elevation is the opposite. So it's basically, you're looking straight, but then looking up would be angle of elevation. So I'll do pink for elevation, I don't know, and blue for depression. Okay, so don't draw this picture yet, okay? Don't draw this picture yet. But like for an airplane, okay, I don't know if you've ever been on one, but like, what is it, like 30 minutes before landing, they say we're going to start our descent. It's usually like a decent amount of time they're going to start their descent. So like you're up in the air and then you're slowly like getting, going down to the ground. And when you land, you're landing like basically horizontal on the runway, right? Like very, very much so horizontal, so you don't like crash and burn, right? Okay. So for an airplane, its angle of depression is 3 degrees. It's like tiny because you're not going to just like fall down. Can you put that away, Emma? Okay. So you're not like 3-degree depression. This is what people do that's like bad. Okay. So they draw their little airplane. I know, it's so good. And like here's your airport. And they're like, okay, the airplane's going to the airport, and then they do this triangle, and they put the 3 degrees here, okay? That's where they put the angle of depression, okay? That is incorrect, because think about that in real life, okay? So think you're flying, and you have to go 3 degrees. You go straight down, nose dive, and die, right? Right? Literal death, right? So this is like people draw because they're not really thinking about it. They're like angle of depression. All your triangles are going to look really similar to this. Like they're all going to kind of look like that, but they put the 3 degrees there. That is super bad, okay? Because this is actually what happens, If it's 3 degrees, okay, it's explosion and death, okay? So, like, because sometimes it's hard to tell, like, if with the situation, but, like, angle of depression, 3-degree angle of depression does not go there, okay? This is the happy way, okay? So you have an airplane. Here's your little airplane. Okay, even this isn't like big enough, you know what I mean? Because it's like a real small thing. So like here's the ground, okay, and you're up in the air and you're going to the airport, but technically, like textbook definition, and I'll show you what I do, is it's going straight in the air, but an angle of depression is actually here, right? Technically, that's my textbook definition. Or if you think about it, you see how like the ground and that highlighter part, they're parallel, right? Think about it this way. When you land on the runway, right, you're almost horizontal, which makes sense because it's 3 degrees. right? So I usually draw all my triangles like this. And then I know it's an angle of depression, so technically it should be up here. But when I draw my triangles, I always put this angle over here by using that alternate interior angles. And it helps me remember like this airplane thing. Like I want to like gradually hit the runway, okay? So this is the correct way to draw it. Like you put the 3 degrees in the correct spot. So sad things don't happen, okay? So the happy face is what you want to do, okay? And we'll do some examples. So if that still is kind of fuzzy, it'll hopefully make more sense. Okay, so this first one, this is the best question on tests because you just have to like write some words. So describe each angle as it relates to the diagram. So there's going to be like some random pictures and stuff. And essentially, like for angle 1, what you do is just figure out where the horizontals are. Like all these are going to have horizontals. Horizontals like left to right, right? And then it's an angle of elevation if the angle is above the horizontal, and an angle of depression if it's below the horizontal. So like for this first one, you're looking like it's down, like the angle's below that green line, the horizontal line. So this is going to be an angle of depression. And then you say from what to what. So whoever has the horizontal is like what's looking. So this is going to be from the birds to the ship or boat or whatever you want to do, okay? So the birds are looking at the ship, okay? Like they're looking down at the ship, okay? Angle 2, now you have to figure out if angle 2 is above a horizontal or below a horizontal. So since it's above, this is going to be an angle of elevation. And then you look at like what's looking at what. That's like, here's your horizontal. You're looking from the ship to the birds. I almost said like boards. That was weird. And then angle 4, you have to decide if angle 4 is above or below the horizontal, right? So angle 4 is above the horizontal, so this is going to be an elevation again. And then you say what's looking at what. So the submarine has the horizontal one, so you're going to write submarine, and it's looking at the ship or the boat or whatever you want to say. I'm not going to be picky about that. It's more about like, do you have the right order? And whether it's elevation, depression, okay? All right, so these questions are tough because you have to draw them yourself, and these are worth 2 points on the quiz and the test. You get a point for the picture, like having like the variable in the right spot, the angles, the sides, and all that. And then it's a half point for your setup and a half point for your answer. So really, most of the points are like in the work, okay? So just kind of be cognizant of that. So here, Karen is standing on top of the bluffs looking down at the UW lacrosse track on campus. I don't know if you've been at, you know this, but State goes to UW lacrosse for their track meet. Okay, so the bluffs, they're kind of like, what do you want to say, mountains or something? I don't know. This is a bluff. Wow, that's so good. Okay, so there's going to be there's going to be 2 levels, right? So my advice is like draw the ground, okay? So we have the bluff and then we have a track, which is whatever. That's the track. Just go with it, okay? We're just going to go with it. And then Karen is standing on top of the bluffs. So there she is. She's on the bluffs. Yay. Stick figure, okay? And Karen is looking at the track. Okay, so they're always looking at each other. So that's always going to be your hypotenuse. Okay, at an angle of depression of 32 degrees. And again, remember the airplane thing. Okay, you have to put the 32 in the right spot. Okay, so don't crash and burn. Okay, you have to put the 32 in the right spot. Now, I kind of do the little cheat way because a lot of my triangles look the same, and I use that alternate interior angles. But technically, if Karen's the one looking, she's looking straight and then down at an angle of 32. But what I'm saying, I usually put that 32 down here because then all my right triangles look the same, you know? So all I did was alternate interior angles. So like technically she's the one looking, but that angle using the parallel line concepts, right, is over here too, okay? And then you're gonna put the base of the bluffs. So the base is like bottom. Base of the bluffs is approximately 300 meters from the track. So 300 is gonna go here. And then how tall are the bluffs she is standing on? So this, you can be wild and use H for height instead of X if you want to be wild. So this picture right here, it doesn't have to be fancy with stick people, but you need at least this right triangle with the 32, the H, and the 300 in the right spot. Okay, so as long as you have a right triangle, you'll get all the points for the picture and put the stuff in the right spot. Because then now it's just like your old like SOHCAHTOA stuff. So you're going to be finding angles or sides. It just kind of depends. So base, what do we do? Here's the angle. So it's like all about the angle, and you have to decide if H and 300 are opposite, adjacent, or hypotenuse, right? So this one's what? Opposite, adjacent. So TOA, tangent, right? So we're going to do tangent of the angle. So this isn't what we did Friday, right? We're not going to do the inverse thing, the second tangent. This is like the quote-unquote normal ones. So tangent is opposite, adjacent. Put this over 1, and then you're just going to tap this guy in your calculator. Double check that you're getting the right answer, but you're just doing 300 times tangent 32. That's all you're typing. And then you get 187.5 meters. So just make sure you have your unit, round to the 10th. Make sure you get the same number. So this is what, as far as points go, the picture is a point, this setup is a point, and then the answer is a point. Okay, so these ones are worth more, but it's more in the work. Okay? All right, we're just going to do 2 more. I'm not going to do this number 4, so you can like cross that out. If you want to, you can. There's a more efficient way to do that than what we have already. Okay. All right, so there's always this kind of problem and like different variations of it. Guys, stop talking, please. Okay, different variations. So a person standing 30 feet from a flagpole can see the top of the pole, like good for this person, okay? If the person's eye level is 5 feet from the ground. So there's like an extra aspect to the height, okay? So please, like no offense, but like some of these people, it's like people draw the person and then they draw the flagpole. And I'm like, dude, where's the ground? Like, draw them normal. Like, now you have a levitating person. So, like, when you're drawing these pictures, like, draw the ground. And it's always, like one on lower and one above, okay? So, like, be obvious so it's not confusing. So, like, a person is smaller than a flagpole. So, draw your little guy on the ground, right? And then draw your flagpole on the ground, but like up a little more. You know what I'm saying? So then you're not getting like, you're not confusing yourself with all the pictures. So, person standing 30 feet from the flagpole. Okay, so 30 feet from the flagpole, okay? Can see the top of the pole and an angle. So the person's looking at the flagpole. Okay, it's always going to be a hypotenuse or something. Usually, like if they give you a length for that, it's usually like line of sight is common, or direct distance to. That's usually like for the vocabulary for that part. Okay, and an angle of elevation 35 degrees. So here's the deal though. They said the person's eye level is 5 feet from the ground. So there's like a little, it's not like they're laying on the ground. Like my right triangle isn't like just with the ground to the flagpole. You've got like an extra piece here. You have this 5 feet. So when you're doing this, because you have to find, what is the deal of height of the flagpole? Clearly nothing better to do. Okay, so this is going to be my height. So my end goal is to figure out the height. But then when you're doing this, it's really like you're working with the eye level first, okay? So like when they give you a height of the person or they're standing on something or whatever it is, do the horizontal with the eye level. Because then what you're going to do, like the end goal, is you're going to figure out like most of the flagpole, and then you're just going to add in the 5, okay? So like there's like an extra step to this kind. So I didn't even put the angle in. Angle of elevation, 35-degree angle of elevation. So again, 35 from the person up to the flagpole. So what I'm going to do is I'm going to scooch up this 30 and then find like that X, so like most of the flagpole, and then add the 5 in. So that one's like a little harder, I guess, because you have to do all that. And then what is this, SOHCAHTOA? So is this tangent? Yeah. A lot of these are tangent because it's easier to measure horizontal and vertical distances versus like a hypotenuse. Okay, so what did I say? Tangent. So tangent 35 equals, and then I'm going to do opposite over adjacent. Oops, not 330. Cross multiply. So I'm just going to tap that guy in. So 30 tangent 35 gives you 21.0 is what I got. So that's like most of it, right? Like most of the flagpole, but remember, you have to add in the person's height. So your end goal is to take the 21.0 and then add in the 5 feet. So that one can get kind of tricky. Oh, and don't forget unit feet. So now you guys can figure out these things. Wow. Okay. All right. Is there any questions with that? Okay. So again, this picture, don't get sloppy. That's worth a point. Okay. I need to see at least a distance, right, of 5 feet, not just the right triangle on this one, right? You got to show all that picture. Okay. Well, I'm not doing that one. A lighthouse and a boat. Okay, so think of one, which one's the higher one, which one's the lower one, and that's how you like draw your picture. So you draw a lighthouse, which try not to be too stunned by my artistic ability, and this one doesn't say like the height of the person or whatever in it. You know, like they're not saying like the eyes are 5 feet or something. So I'm just like assuming the person's like in the lighthouse or something. Like that's not going to have to be a factor I deal with, is like the height of the person. And then they're in the lighthouse, and then we can be like, there's the water. Cute. And then there's a boat. Wow. There she is. And the person's looking at the boat. Right? So, what do I need? The top of a 105-foot lighthouse. So what is that? 105. So we know how tall the lighthouse is. 105. Angle of depression. Remember the airplane. Don't crash and burn. Okay? Put the angle in the right spot. Okay? So if you want to die, literally, you would put the 37 there. Okay, that's the death mistake. Okay, you put the 37 there, that's the death. Remember, textbook definition, it's horizontal, and then angle of depression's 37. But I kind of do the cheat way where I always draw my triangles like down here, and I put the 37 here. I use like alternate interior angles. And then they're asking me the distance between the base of the lighthouse. So it's like the bottom and the boat. So the X is here. And then you figure out if it's sine, cosine, tangent. I unfortunately didn't put in finding angle ones, but you could technically find angles with these two. So that would be tangent 37 opposite 105 over adjacent X. Cross multiply. If you've noticed the pattern with solving these, please go right ahead and use what you know. with this cross multiplying business, and then you're just tapping around, and you get 139.3 feet. That's the answer. So it's mostly just kind of